Hi friends, this is Arun. In this video, we'll have a look at linked list. Okay, so linked list is one of the important things which you should learn in C or data structure. That's the way I would put it, and spend time in learning this. It's worth spending it because if you learn this using any language, C, C++, Java, Python, it doesn't matter. If you have the clear concept of or understanding of linked list, and if you are able to implement it, the rest of the all the other data structure would be a cakewalk for you. So before going into the topic, there are few things which we need to recall. One is what is a variable, array, structure, and a pointer. All these things you should recollect before getting into a linked list. Let's do that. A variable is a thing which holds some value. Okay, that is a variable. Whereas if I want five variables with the same name, that is called an array, which stores consecutively all the values and it is accessed through the index. Whereas structured is like I have a different type of variables. For example, one int, one float, and one character. I want to pack it and call it with a single name. That's where structure comes into play. Okay. So the difference between array and a structure is array is always holds same data type. If it is int, it will have only all ints. Whereas structure, it can have a combination of things. That is homogeneous. This is heterogeneous. Okay. Let's go to the pointer. Pointer is also a simple variable like the first one, but it holds an address. That's all the difference is. Okay. So to mark the difference, all we are doing is like putting a star over it. In the real world, everything has two phases: static and dynamic phase. Static is which is not changing your core natures, whereas dynamic is your behaviors which you acquired from through your friends and your society. All those things. Same thing applies to memory as well. Static is like when you know the exact thing, you'll fix it. Typically, you solve it with a simple array. In dynamic, where you don't know when you are going to or how much you are going to get in. For example, average of your sum of your semester marks. Obviously, you know your number very fixed, and then doing you will be able to directly declare it. Whereas in the case of dynamic, uh, it might be for multiple departments. Every department might have a different numbers of papers, so there would be a difference in the memory usage. Okay, so some college, if it's arts college, they'll have a less number of paper. If it is engineering college, they have more number of papers. If it is a medicine, it will be have multiple years and multiple repetitions of papers. Okay, all these things finally stored in variables, arrays, and structure and pointers. That's the reason why we start we recalled all those stuff. Okay, so you'll be more familiar with the first three things. It is straightforward. The scary part is the pointers, and the pointers comes into play whenever there is a dynamic memory allocation is needed, or whenever there is a dynamic need for it. Okay, so if it is a static, you can solve it with the first three types itself. You don't have a trouble at all. Okay. So let's assume I want to. I mean, when we say dynamic memory, what it happens like whenever you do a malloc or a do, it gives a array of memory or chunk of memory. Okay, you put that chunk and then link it to each other. That's where the linked list comes in. Okay, so let's expand the same problem into the next level. So if we pick the first problem which we have seen in the last slide, sum of your semester marks. Okay, all you need to do is declare eight variables or an array of eight variables, or even if you want to dynamically allocate eight, it's fine. Finally, you will get a fixed size of memory. Whereas if it is a department thing, you may not know what how many number of variables you need. It could be 40, it could be 60. If I declare an array of 60, what I'll be wasting around 20 if the total number is 40 only. Okay, so the same problem goes with the structures. So during this case only the dynamic memory comes into play, where I clearly say that I want only this many number of the this much amount of memory based on the user input. So finally, if you see that both looks same, only difference is how much I want to waste is the key difference between these two guys. Or else both the problems can be solved in the same approach. So if you see the code, like in the top I have declared an array with marks 8. The same I have declared with the pointer marks 8. So there it is a fixed size of 8. The second choice it is dynamic size of 60. Now I have given 60 there. Instead of 60, I'll get it in n, like some other variable, and multiply that variable over there. N into size of int. I can do. So the trade-off I am taking is like simplicity versus efficiency. Okay, now let's move into the linked list. We have spoken enough about the dynamic memory. So linked list is nothing but a sequence of objects which is connected through a link. Okay, each chunk is called a node. The node will have an element, okay, probably the value which it's supposed to be holding, and also who is my next thing. In school we used to stand in the line, right? So holding each other, the same thing we'll do it with the programming here. Okay, so we'll see that data visually. So imagine that it's a rectangular box. The box with one part it is having the data, and second part there is a chain which is having a hook. It's like a train compartment, think about it. Okay, so and everything is linked to each other. Okay, that's why it's called linked list. It's a list which is linked to each other. So whenever you want to traverse to the next node, all you need to do is pick the link of the next node and go to the node, which would be the address ultimately. And if it is the last node, the address would be set to null, straightforward. Okay, so this is how the linked list is constructed. Always remember this diagram visually. Let's see a better example. For example, if I want to have a sequence of names, I can have it like that: Madurai, Chennai, Mumbai, Bangalore, like that. Or else if I want to store an integer value, I can do it. And if I want to have a structure, I can also put a structure inside it. Okay, it could be anything which is linked to each other. So here I have put in the structure for it, like first is the name, second is the address, okay, third is the phone number, and the next link node. It's a combination of multiple things. Okay, this is a simple straightforward single element stuff. Okay, so to make it simple, we'll keep with one data value and then start playing around it, because we have to handle the pointers troubles first. So we'll address that and then we'll go doing multiple elements in this. Start from the first thing: how to allocate the space for the first node and how to set a pointer for the next value. Okay, so let's graphically see that. uh, there are three parts. One is the data part. First we have to create the memory and put the data and also set that. Okay, how we are doing it: the address is the structure name star new name, which is a pointer, like integer star pointer. Okay, it is going to store that malloc of size of address. Okay, because it's one element. So that's the first step which we are doing it. We are allocating the memory. Then we'll get the data. Okay, what are the data? Name, address, and phone number. Okay, and finally we'll set the next to null. That's it. Very simple and straightforward thing. But watch it clearly. Since it's a pointer, we use it an arrow mark. Okay, all those things, look at it and then try to understand. Okay, so go and refresh your structures. Simple pointers. The simple pointer here is new name, and it is of type struct, and then we pick the data. Switch the topic to array. So let's declare an array of 5 and then try to do something with that. So declaring array and using array is the simplest thing. But the constraint is it is of fixed size. Still the program ends. You can't increment, as I said. But the bigger trouble is insertion and deletion at the middle. In the front and rear, you can easily do it, no issues. If you are doing it in the middle, what you do, you have to shuffle all the elements down, or else you will be overwriting the values. So that is the thing. That point can be replaced efficiently with the linked list. Okay, all it is a structure, the structure name, and it has the ability to grow, whereas array is a fixed size thing. And then you can insert any place anywhere. Okay, directly. But the trouble is, like here with the linked list, it is little slow in terms of searching. Whereas if in even in array, if you want to search all the elements, it's a little slow. If you know the index, it is much faster. Okay, so let's again start with the node structure. For a simple node structure, I have a structure with the mark and the next item. Let's create the head pointer. I am just declaring it like it's same as kind of int pointer only. That's not much difference. That's why I shown the example with that. Okay, let's display the things. So let's start with the head, and till it's not null, what we are going to print the current element mark, and then we have to move the pointer. So it starts with the head pointer and then comes to the print and then goes to the next and goes to the next, like that. It goes till the null it comes in. Okay, meanwhile we in between we are printing the values. Okay, so that's about the thing. So let's go back and create a node. Now we have seen the simplest form, which is the display node. Now we'll go and create node. What are the steps? First we have to get the head pointer, okay, and then create a new node and assign the values. Okay, let's assume I want to do modify this thing 10. Okay, there might be a condition, the list may be empty or it may have some nodes as well. Okay, if it is empty, so I have to create the head pointer and point it to here, or else I have to add wherever it is and then adjoin the other things over here. So the first thing is the empty style, like the above head one. The below head one is the one with the linked list with some elements. Okay, let's see how it goes on. So let's start with the head pointer, and then we use another pointer called current pointer, so that we can use that for traversal and finally end at the append at the end of the thing. Okay, so let's do that. First we are declaring the node struct list item, and then we are making it as null. Then the memory allocation happens, then we are setting a value. After setting the value, we are setting the next to null, so assuming it is going to be the last node. First step, what we check whether the head is null, which means that the list is empty, or else what we have to do, the what we did in the display, so we have to traverse till the end and then print it. Okay, so while of next, finally null will come. So instead of null, we'll hook up this pointer over there. Okay, the same code I'm showing it in the notepad, nothing different from there. Okay, so line by line it is there. So while, and then finally we are hooking the new node at the last line, current node dot next equal to new node. New node is the one which we have created in the line 2. Okay, let's go and run it up. So it's compiled. So next step is to run the exe list.exe. Finally it will display, append and display. See, we have got all the values printed here. So what we are doing here is, like, we are doing multiple create nodes, so that every time it calls it, new node is added. Then finally we are calling a display, and then also we are doing a delete node to make sure the deletion is happening properly. So the next slide we'll look into the deletion part. Before that, like, we'll focus on create node. So straightforward thing, if the node is null, put it as a head, or else traverse through it. Okay, now let's go to the delete node. This is the trickiest thing, which you have to carefully watch it, because so in deletion here everything is a link, right? So if you delete a link unknowingly, what happens is your entire linked list is lost. You don't know where it is present. Okay, so what we have to do is, like, first start with the head pointer and find the node which you want to point, and then before deleting it we need to do one step. Okay, we'll see the step. Let's assume this is the list I have. Okay, and current pointer is at the initial stage, both head and current is same. So I want to delete this node. Okay, so that is my expectation. So what is the next step I have to do is, like, so if I directly delete it, that's it. Like, this is how it is. Like, your current pointer would be dangling and the rest of the linked list would be gone. Okay, so that's why I was saying, like, we need to have one more step before deleting it. So we take the temp node to delete the node which has to be deleted to a temp pointer, and then we point the head to the next node, the red line which we have shown it. Okay, so by that way the temp pointer is there, and then once it is there, we can delete the temp pointer clearly. Okay, so this is very very important, so observe it and then carefully do it. Okay, if you are able to write create and delete node, you are very good in linked list. Even first start with, as I said, display, and then create and then delete. Okay, it's same as the thing. So I have a current pointer, temp pointer, and a previous pointer. So while current is not null, I am just traversing, and I am checking whether the mark is the one which I am expecting. So if it is found, what I am doing is I am storing the current pointer to temp pointer, and then the previous pointer I am setting it to current one, and then current is equal to current dot next. So we are jumping one level ahead, so that we don't end up in the deleted node. Okay, And finally, what we do is we come out and then free the current node, which is the temp node. Even it could be a temp node. You can delete temp node. Both the things are the same. Okay. So these are the basic things. So watch carefully and do it. Thank you, friends. Bye bye.